welcome to this Catia 3D Master and Composer seminar. Today, 3D is commonly used across the design process, but many companies are wondering why, despite their investment in 3D, they still suffer from errors and delays. The reason is, for many, 2D remains the master reference for the product definition. This is also the case for downstream deliverables. Let's take a quick look at some of the business challenges that companies still using the 2D master approach are facing today. One example is quality. Here we see a wire harness which is too short and can't connect. This is common and was the story in a high-profile aerospace project where the poor fit on the wire harness jointly developed between multinational participants led to a hugely expensive recovery plan and delays to the program. In architecture, it's not unusual to see absurd results realized in production based on what is described in the 2D drawings. A door blocked by another structure, or a staircase which leads to a dead end. Have you ever bought a car and after 6 months discovered the quality created is not sustainable in the midterm? In this case, a glove compartment does not close correctly because it was incorrectly designed. And worse, of course, is safety. When quality impacts safety, there can be a tremendous danger and negative impact. A few years ago, we had a famous automotive example where a car failed an important evasive maneuver test, resulting in major modifications and redesign of the chassis in order to recover, and lost sales. So let's summarize the root causes of the negative impacts of the 2D Master approach. Starting a project with 2D Master, the project information is not simply a single piece of paper. It can come from multiple formats. So the challenge is, how do you work on data coming from different sources that might not be up to date or accurate? There's also no continuity among the stakeholders involved in decision making. The phases are manual and desynchronizing, causing breakage. And something very simple which is still missing, and businesses are spending lots of money on it, is the misinterpretation that drawings can deliver. A simple example here. Is it a diameter or is it an offset? In 3D, we have a cylinder or a rectangle structure, but the drawing is missing the information. How can you make sure your drawing is self-contained with all the information required to fully define the product? Today, there's no answer to that in 2D. 2D inherently has limitations on what can be shown. 3D brings completeness and precise definition. And when you're working with lots of drawings in parallel, depending on the phase of the project, the cost of maintaining the integrity of these drawings during the change process is huge. If you manually change one drawing, it immediately becomes desynchronized from the original data. If someone then makes a change to the 3D model, the drawing's no longer aligned. So the cost of this lack of synchronization is huge. Often with a 2D master, all the issues aren't immediately identified, and the lifecycle costs are increased by the continued use of incorrect and unsynchronized 2D documents, leading to quality issues and customer dissatisfaction. At Dassault Systems, we have developed a response to these challenges. We call this approach 3D Master. It provides companies with one single reference for 100% of the product definition, all in 3D. It means that there's a single source of all product information. It includes a fully accurate and annotated geometric definition. And this single source provides everyone with a source for all manufacturing and work instructions and all downstream processes, and a single traceable source for compliance with regulations and standards. You can still create and use 2D drawings, but they become a communication medium, not the reference, and they're always up to date. The benefit affects all phases of the product development lifecycle. In the conceptual phase, once you adopt the 3D Master approach, it becomes easy to reference and reuse existing 3D and 2D design data with the confidence that it's always correct and has not been modified in the detail drawings. New concepts in 3D can be quickly generated from existing 2D layout. An important thing to remember is that 3D Master and Conceptual Design delivers flexibility to draw in 2D in the context of 3D, simplicity in importing 2D and creating a model with associativity should any engineering change come, and you are beginning to prepare the single model definition created using multiple sources. In the detailed design phase, you can completely define the part with tolerances and annotations directly in 3D, making the definition more accurate and accelerating the development process. The Tolerance Advisor checks and proposes accurate and available solutions, so all information necessary to manufacture the part is captured. Tolerance schema can be rapidly applied to families or similar parts, saving time. And again, the Tolerance Advisor identifies and defines assembly conditions for a total product definition. So what value are we bringing to the detailed design phase? First, we're improving the quality. We are working on 3D geometry, and there is no misinterpretation. Errors are identified early. Product accuracy is improved due to the 3D access. And one of the impacts of that is cost reduction. The model can be reused by any process, including reuse of the functional description among part families. In the validation phase, there is now a single source of all product information. The full product definition is now available for everyone, anywhere, anytime, supporting multiple disciplines and facilitating real-time concurrent design and review, so errors can be identified and addressed early and the cost of change is low. The value, of course, again, is that the product definition is available to anyone, anywhere, at any time, with one single source of product information and one single source of errors. Second, we support multiple disciplines. We also showed real-time concurrent design and review. And the result is decision-making, error detection, and error resolution are all dramatically accelerated. And downstream applications like manufacturing benefit from direct integration and access to the full 3D product definition. Toolpaths, for example, are generated on the exact up-to-date geometry. Downstream users can create their own specialized views and improve their own decision-making, always with accurate data. On-demand blueprint generation allows documentation to be produced for suppliers or other parts of the organization. You can still create and use 2D drawings, but they become a communication medium, not the reference, and they're always up to date. So the value in manufacturing includes on-demand blueprint generation, and we can directly connect the manufacturing to the 3D geometry, referring to the semantic definition to accelerate the toolpath definition. In production and installation, 3D leads to a better understanding. Everyone can have access to the single definition of the product. There's a single, traceable source for compliance of regulations and standards. You can also filter the level of shared information, protecting your intellectual property when you exchange with suppliers and partners. So again, 3D leads to better understanding and removes misinterpretation. Also, intellectual property can be protected by filtering what you want to export. And of course, everyone can directly access the single definition of the product. So now let's take a brief look at cases where our customers are improving their performance with 3D Master. Antoine Scotto, head of the PLM program for the A350XWB at Airbus, said with Catia, we implemented a full 3D Master approach to design the electrical harness installation, which simplifies the process and overall design quality. He also stated, engineers have reduced the time needed to update the installation plan by 50% and decreased the design change requests generated when creating manual 2D drawings by 25%. Everything was installed, fitted, and verified digitally, and if there were any errors, they were corrected before the physical installation. Saab Aerospace is both an aerospace OEM and a major supplier. Using 3D Master, they've been able to achieve a reduction of 90% in change costs and have delivered 3D work instructions to the shop floor. Time spent creating the drawings is now a third of what it was previously. Ford has reached out to their extended enterprise with a communication recommendation to its supply chain to adopt 3D Master, targeting 500 plus suppliers. We've seen how 3D Master can lead to huge costs and productivity gains. Now let's take a look at how we can add Catia Composer to the process and add even more value to your downstream deliverables. First, we'll take a very quick overview of some of the typical use cases for Composer. Then we'll go through a quick use case demo. Lastly, we'll do a quick summary and recap. Here in Composer, we're seeing an interactive presentation showing typical use cases for Composer. Sales and marketing is not only for this type of configurator, but for any time you'd like to interactively explain your product or present information. In customer support and services, you could easily show a service procedure like this disc brake removal. Huge improvements in both quality and productivity have been experienced by our customers in technical documentation and manual creation, with speed and power in Composer in linking and creating interactive SVG documents. Now let's take a look at the engine bracket with the PMI that was created in Catia as it relates to production engineering and quality assurance in Composer. We can see all the original PMI, and now we can create our own views and add any relevant information, or in this case, we can extract the captures directly from Catia. After we save the Composer file, we can use the powerful Open XML architecture to make custom applications like this simple Excel sheet to aid in an inspection process. In this particular sample, we can browse a model and automatically populate thumbnail views so the user can quickly navigate to whatever view they want. They can then inspect and measure the actual measurements compared to the tolerance specifications without having to worry about out-of-date 2D documents. This way they can note the actual measurements and add inspection comments to complete the inspection. Now in Composer, in addition to the inspection and quality assurance on the bracket, engineering and manufacturing can have access to the same data, ensuring the fabrication procedures are followed using the correct measurements and very clear instructions, without having to rely on confusing 2D documents. This has been a quick glimpse of Composer with the advantage of the 3D Master PMI data. To summarize all we said during the presentation. First, we have access to the correct information anywhere, anytime. And the productivity improvement from information is critical. Then, it's also a natural path to go from 2D Master to full 3D Master, and it increases product and process quality. The impact directly is cost reduction, and the savings achieved by customers are huge. Also, we're respecting the standards, and now more and more 3D is becoming a contractual data set. So the cost and quality are available for all who deploy. Thank you very much for your attention on this 3D Master and Composer seminar.